Okay, so the first question says the point 5, -2 is reflected across the x-axis. What are the coordinates of the reflection? So it's asking for coordinates. That means we need an x value and a y value. Okay, so I'm going to go back to my graph where we did reflections, and I'm going to locate point 5, -2. So I start at the origin, I'd move 5 in a positive direction and -2 in a horizontal or a vertical direction. That's going to put it right there. 5, -2. And we want to reflect it across the x-axis. This is the x-axis. So we want this point to go to the other side. So again, I could flip this over if I don't see the pattern yet. And I can look for that point. It looks like it's right there. I can see it through my paper, so that is the reflected point. And you can see that it's on the same vertical line, and it's the same distance from the x-axis, but in the opposite direction. So it's 2 units below the x-axis here, which means it's 2 units above the x-axis there. So the coordinates would be a +5 and a +2. Okay, now let's just think about, could we have done this without drawing this problem? Well, 5, -2 is your point. If you're reflecting across the x-axis, that means you're going to the other side of the x-axis. Right now, then, the horizontal movement of 5 is not affected by that, right? It's the vertical movement up and down. So if we went down to begin with, then we would go up 2. So now let's try the next one. The point -6, 8 is reflected across the y-axis. That means we're going to go this way, back and forth. What is the coordinate of the reflection? So again, because it's asking for a coordinate, we're going to have an ordered pair as our answer to this question. So -6, 8, I could graph. -6, +8 would go up here. And if I wanted to reflect this across the y-axis, that means I care about it going this way, here to here. That means it needs to go to the other side of the y-axis. So if I'm 6 spaces here, I would go 6 spaces on this side, and that would be the reflection over the y-axis. So our location here is +6, +8. Okay, and if you can't see the pattern, just to do it mathematically, you can always draw it on a coordinate plane. Okay? All right. The next questions ask you to use the coordinate plane to the left or to the right here. And it's asking for the distance between point A and point B. So here's point A, here's point B. Okay, now you can see that they are lined up on the same vertical line, which makes it a lot easier. So we're counting how far it is to the y-axis and then to point B. So we can start here, count the distance to the y-axis, which is 5 units. And then because 5 is the x value, the x value on B is -2, so we need to include that, but we're going to do it as its absolute value. So 5, the absolute value of 5 is 5. The absolute value of -2 is 2, which makes it 5 plus 2, which is 7 units. If you counted, you would count 1, 2, 3, 4, 5, 6, 7 units across. Okay? Now the distance between point A and point C. Point A and point C. Now this one's a little different because they're both in the same quadrant. They're in quadrant 4. Remember, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So if you want to know how far they are, we can do the same thing. We can start with, you can see that if you look at these, this has a ordered pair of 1, -3, and this is 5, -3. So the -3s are the same, right? So then we're going to find the difference in the other points. So we could say that, let's start with the A value. A point, the x value is 5. So we're going to think about the absolute value of 5 minus the absolute value of this x coordinate, which is 1, is the same as 5 minus home, which is 4 units. And you can count it 1, 2, 3, 4 units across. Okay. The next question says to plot the reflection of point C across the x-axis. So we need to do that first. So we need to put point C, its reflection over the y-axis. So here's the y-axis. So we want to put point C on the other side of the y-axis. So if C right now is here and it's 1 unit away, we're going to put it 1 unit away on the other side. And then we want to count the distance between point C and its reflection. This is the reflection. So point C is 1 unit away from the y-axis. Its reflection is also 1 unit away. So that makes it 2 units from each other. Number 6 says to do kind of the same thing, but now we're going to look at point A and we're going to reflect it across the x-axis. So here's point A. This is the x-axis, so we want to place its reflection on the other side of the x-axis. So right now it's 1, 2, 3 units, so we're going to go 1, 2, 3 units in the other direction. So now what's its location? Well, if you start at the origin, you move 5 to the left, right, and then 3 up, so 5, 3. So what's its distance? It would be 5 units to the x-axis plus another 5 units. So we did something wrong there. What's the distance of the reflection from the x-axis? Sorry, it doesn't want to know the distance between the 2 points. It only wants to know the distance from the reflection to the x-axis. So here's a reflection, 1, 2, 3 units to the x-axis. Got to read those questions carefully. Okay. So now we're going to use the map that's shown here on a coordinate plane. It's every grid on the map represents 1 city block. Okay, so Yoko walks from the library to the mall. Let's see, here's the library, here's the mall. How many city blocks does she walk? Well, you could count them. They are on the same horizontal line here. So from the library, it's 1, 2 units there, 1, 2, 3 units there. So 2 plus 3 is 5. 5 units, but each unit is a city block, so we would say 5 blocks. All right, so if Yoko walks 1 block in 3 minutes, how long does it take her to walk from the school to the library? Here's the school. Here's the library. How long does it take her to walk from home to school? So there's 2 questions here. Okay, so let's work on school to library first. So far, what we need to do is figure out how many blocks it is, and then we know that 1 block takes 3 minutes. Okay, so how far is it? Well, how far is it from the school to the x-axis? It's 1, 2, 3 units, and then from the library, from the x-axis to the library is 1, 2, 3, 4 units. That makes 3 plus 4 is 7. It's 7 blocks. Every block takes 3 minutes, so that would be 7 times 3 is 21 minutes. Same question asked from home to school. Here's home, here's school. Now home, you might notice, is in between 2 of the grid lines, and that's because the x coordinate is -3 1/2, but that's okay. So how far is it from home to school? Well, it's a half a block plus another block makes it 1.5 blocks. And 1.5 times 3, 1.5 times 3, 15, 45, 1 decimal point, 4.5. So 4 5/10 minutes. Okay. So the last essential question check-in says, how do you use absolute value to find the distance between 2 points that have the same x coordinates but different y coordinates? So let's just think about that. Let's come up with an example for ourselves. Same x coordinates. So let's say 1, 3. Different y coordinate would be 1, -3. How about that? How do you use absolute value to find the distance between these 2 points? Well, can you tell me what the difference between these 2 points would be? They have the same x value. This one is 3 units away from the x-axis, and this one is 3 units away in the opposite direction. So we would add 3 plus 3. So we would take the absolute value of 3 plus the absolute value of negative 3, and that would be the same as 3 plus 3, which is equal to 6. And so here I showed the explanation as opposed to using words, but that is the idea. Okay? All right, so you guys are going to work on page 407 today on your own. Make sure you upload it to Google Classroom, and have a great day. Talk to you later.